Hey there, if you're a scientist, you know this feeling all too well. You've got this amazing, groundbreaking idea, but you end up spending your days just fighting with your own software. Well, today, we're going to talk about a way to get you back to the actual science by tackling those technical headaches in bioinformatics once and for all. So let's just cut right to it. I've got to ask, is your software slowing down your science? I mean, really think about it. Are you spending more time trying to fix code than you are actually focusing on your research? You know, for so many brilliant researchers out there, this is just the daily grind. Instead of making those big discoveries, you're stuck debugging, you're wrestling with these fragile, clunky systems, and let's be honest, you're basically working as a part-time programmer you never signed up to be. And this all leads to a huge problem, something we can call the bioinformatics bottleneck. It's that exact point where slow, fragile software isn't just wasting your precious time, it's actively putting your results at risk. A lot of labs are, frankly, running on these old legacy systems that are just packed with what's called technical debt. What that means is they're super inefficient, they're prone to crashing, and worst of all, they can actually jeopardize the integrity of your entire research project. Okay, but what if you could just hand off all of that technical stuff so you could focus purely on the science? Well, that's where a new breed of builder comes into the picture. Introducing Oak Bioinformatics. And their mission, it's really a powerful promise. Enjoy your research, leave programming to us. I mean, that simple statement says it all. It gets right to their core belief that researchers should be free to push science forward, not get bogged down fixing code. So the big question is, how do they actually deliver on a promise like that? Well, the secret sauce is in the programming language they use. So let's dive into what they call the Rust-powered advantage and see what makes their whole approach so radically different. The key concept you need to know here is memory safety. Now, the simplest way to think about it is, it's like building with smart Legos that literally won't let you connect the pieces in a way that could make the whole thing fall apart. It's a feature baked right into the language that prevents an entire category of bugs that cause those frustrating crashes and security holes. It's like having a built-in safety net for your software right from the start. And look, this isn't just some niche tech trend we're talking about. The White House itself actually recommends using Rust for building critical government systems, and they call out its memory safety as the specific reason why. I mean, an endorsement at that level, it really speaks volumes about how reliable this language is. So let's put it side by side. It becomes crystal clear. On one side, you've got the old legacy systems. They're slow, they're prone to errors, and they're super fragile. But on the other side, you have Oak's Rust-powered systems. We're talking blazingly fast, memory safe by their very design, and just production-grade robust. The difference, honestly, is night and day. Okay, so what does all this tech actually mean for your lab? In the real world, what can Oak Bioinformatics actually build for you? Let's take a look at their solutions for modern science. They really focus on four core things. First, engineering these high-performance systems from the ground up, built exactly for what you need. Second, developing custom products and tools made just for your unique research. Third, and this is a big one, optimizing and even rescuing your existing slow software. And finally, offering expert genomic data analysis to help you pull out those key insights. And to make this super concrete, just look at their RNA-seq analysis service. They've managed to turn this incredibly complex process into a simple, streamlined, four-step workflow. It starts with scoping the project and goes all the way to delivering publication quality figures that are ready to go. It is a complete end-to-end solution that lets you focus on the results, not the tedious process. Now, of course, having powerful technology is really only half the story. You also need a partner that you can absolutely trust. So let's dig into the Oak Bioinformatics process and see how they deliver results that you can actually rely on. First up is their deep experience. The team brings more than 20 years of expertise in building these cutting-edge bioinformatics tools. And get this, many of the tools they've built have been used continuously for over a decade. That right there is a huge testament to their quality. And that kind of experience has earned them a serious global reputation. Over 200 users all around the world rely on the software that they've developed. That's a pretty strong signal of the trust they've managed to build within the scientific community. And their client list, well, it really speaks for itself. They're trusted by some of the most respected research institutions on the planet, including the NIH, MD Anderson Cancer Center, and Johns Hopkins. I mean, partnerships at that level tell you everything you need to know about their capabilities. And working with them is designed to be completely straightforward. It's a simple, transparent, three-step process. First, they hop on a call to really scope out your needs. Then, they develop the solution with you with regular feedback calls. You're always in the loop. And finally, they deliver a finished turnkey system that's just ready for you to start using right away.
When you put it all together, it all points to one clear goal: supercharging your research. And believe me, they are not stopping here. Let's take a quick glimpse into what's coming next.
Right now, they are building the successor to their already popular Oak platform. This is a next-generation genomic annotation system, and it's being written entirely in Rust from the ground up, which promises even more performance and even more reliability. So, what's that mean for you? Well, first, it's memory safe. The whole system is built on that rock-solid foundation of reliability we talked about, so you can say goodbye to those frustrating memory-related errors and crashes. Second, it is blazingly fast, and we're not just talking a little faster, we're talking orders of magnitude faster. That is a total game changer when you're dealing with massive genomic datasets. And finally, it's built for enterprise scale. This platform is being engineered to handle absolutely enormous genomic datasets and complex workflows, so it can scale right alongside you, from a single researcher all the way up to a major institution. And so, we end up right back where we started, with their core mission: enjoy your research, leave programming to us. In a world where scientific progress is more critical than ever, maybe the most important innovation of all is giving our best and brightest researchers the freedom to do what they do best: discover.